In order to solve some logarithmic equations, it's often necessary to condense them into two logarithms into a single logarithm. So that's what we're going to do in this example. Good thing we know how to do this using our properties of logarithms. Since these two logs are being added together, my property says I'm allowed to multiply these two pieces together in order to condense into a single logarithm. So I'm going to begin with writing log base 5 of, and I'm going to go ahead and multiply x plus 6 times x plus 2 together. I'm going to do that in my head. If you need to use the box method or FOIL to do that, that's fine if you need to double check my work. But multiplying x plus 6 times x plus 2 will get me x squared plus 8x plus 12. And then equal to 1. From here, I'm going to go ahead and rearrange this problem so it's no longer a logarithm, but so it's exponential. This was one of our tricks we've used for solving logarithms before. So 5 is my base. Raised to the first power needs to be equal to this part right here, x squared plus 8x plus 12. You could also solve this problem by exponentiating, which we've talked about before, but I like to just use that trick and rearrange them. So I end up with this quadratic equation. Well, if anything's quadratic, I know it's got to be equal to 0 so that I could try to factor it or use the quadratic formula. So what I'll do is I'll subtract 5 from both sides in order to get this equal to 0, and I end up with the equation that I need to solve of 0 is equal to x squared plus 8x and then plus 7. I can try to factor this. If factoring doesn't work, or if I don't want to factor it, I can use the quadratic formula. Oops, I got equals 0 in there twice. This one factors pretty easily. Numbers that multiply to 7 but add up to 8 would be 7 and 1. So I can factor this into x plus 1 and x plus 7 equal to 0, which means two answers I come up with if I put each factor equal to 0. X could be negative 1 or x could be negative 7. Now recall, if you've watched the other videos or paid attention in class, that we cannot do the logarithm of something negative or something 0. Now that doesn't necessarily mean automatically that if you get an x value of an x that's a negative value that is extraneous, all it means is you can't do the log of a negative number. So what I'd have to do is take each of these values and check them in the original problem and see what would happen. For example, if I plugged in negative 1 for x, well, negative 1 plus 6 is 5. 5's positive, so that part's fine. Checking over here, negative 1 plus 2 is 1. That's also positive. So negative 1 does not result in me taking the log of anything negative or 0. So negative 1 is a fine solution to this problem. Compare this, though, to what happens when I try negative 7. If I take negative 7 and plug that back in for either x in the original problem, well, negative 7 plus 6 is negative 1. That's bad. I cannot do the log of a negative number. If I check over here, negative 7 plus 2, well, that's negative 5. Again, negative. It doesn't matter. If any of them's negative, you can't use it. So negative 7 I would have to cross out and say it's an extraneous solution. It does not work. So the only solution to this problem is negative 1.